We used red cabbage juice as our indicator. Red cabbage juice contains anthocyanin. Anthocyanin is a pigment inside the red cabbage that secretes the color purple when boiled. We added various solutions which changed the color.
Acids release hydrogen ions and bases release hydroxide ions. Hydrogen ions are hydrogen atoms that have a positive electric charge, and hydroxide ions are hydrogen atoms attached to an oxygen atom with a negative charge.
Anthocyanin becomes an indicator because different compounds react differently with light. Acid-base indicators change color because their structure changes in different ways. Acid turns blue litmus paper red, and bases turn red litmus paper blue. One example of an acid would be a lemon because of their sour taste, which means they have high acidity. An example of a base would be soap because they taste bitter and have a slippery touch, which means they contain more basicity.
First, we boiled our cabbage, and we put the water into separate test tubes. We began to add various solutions to the different tubes and observed their color change.
The solutions we added were sodium bicarbonate, which turned emerald, acetic acid, which turned magenta, ammonia, which turned green, hydrochloric acid, which turned bright red, and nitric acid, which turned lime green, and boric acid, which stayed purple.
Sodium bicarbonate turned emerald because it had a pH number of 11. Acetic acid turned magenta because it had a pH number of 3. Ammonia turned green because it had a pH number of 12. Hydrochloric acid turned bright red because it has a pH number of 1 because it was an acid extremity. Nitric acid turned lime green because it had a pH number of 13 because it was a base extremity. Lastly, boric acid stayed purple because it was basically water. The pH scale measures how acidic or basic a substance is. On the pH scale, 1 through 6 acidic, 8 through 14 is basic, which makes 7 neutral.